Okay, Assalamualaikum and very good day to all of you. So today we're going to continue our lesson with a moment which is produced by a couple. Okay, so next part I will introduce you what is couple and how can this couple can contribute to a moment. Okay, for next part we'll cover about a moment of a couple. So what is couple? Okay, so in engineering mechanics, okay, the couple is actually derived as a when there is a two force which is with F and negative F, okay, which having the same magnitude, the same value. Okay, for example, it is a 10 Newton. So this one will be negative 10 Newton. Okay, and parallel lines in lines of action, parallel line of action, for example, like F in this direction. So it another force, okay, which is this direction. So it shows that the line of action is parallel, okay, and opposite sense. Of course, it's opposite. So that's why one is pointing outward and the other one is pointing downward. So this one is become negative F. Okay, so are said to form a couple. Okay, so it looks like this. Okay, so what I can make analogy for you is like human. Okay, a man and woman which has negative different genders. Okay, with same feeling. Okay, so they are said to be a couple. So same like first. Okay, so when you look at this one, okay, these two forces is actually creates a couple. The simple example I can explain to you is like imagine that you are holding a steering of a car. Okay, so in order for this steering to turn into clockwise direction, okay, you need one force which is on the right of the steering pointing upward. So that means your hand slightly push up the steering towards the upward direction, and the other hand, okay, sorry, my drawing is not that good. Okay, and the other hand which is left side of hand, okay, pulling this steering. Okay, so it apply a force towards downward direction, so it's become negative F. So what will happen, this couple will produce a moment, so it will produce a rotation towards the steering. Okay, and this couple produce a moment. So we know that this couple produce negative moment because it rotates on clockwise direction. Okay, so we know that this couple, this moment is negative. So negative moment in which that m, in order to calculate the moment, still use the same formula which is F times T. Okay, so in this case, okay, the F itself, since that both forces has the same value, so we just choose one. For example, in this case, like let's say this one is 10 Newton. So this one just put the 10 Newton. Okay, and times with D. Remember, D is perpendicular distance. Okay, before this, we learned that D is perpendicular distance from the reference point. But when it is referred to the couple, moment due to the couple, D is actually perpendicular distance between the two couple. Okay, that's mean these are the distance that you have to use. So for example, let's say this one is 0.1 meter and you just multiply by 0.1 meter. Then you will get the value of the moment due to this couple, which is 1 Newton. Remember that it is rotating on negative on the clockwise direction. It's become negative 1 Newton meter. Okay, so let's take a look at the other example. Okay, so for example, like this one. Okay, there are two couple of this force. Let's say this one is 30 Newton and the other one is negative 30 Newton. So where is the perpendicular distance? Okay, so you have to find the distance, the perpendicular distance between the two forces. Okay, The easiest way is you just place your ruler in between this line of action, so you will get this straight line which cause the 90-degree angle is actually your distance. Okay, so now refer to this one. Okay, so this is a couple as well. Okay, so where is the rotation? What is the direction of the rotation? Okay, so one of the force pushing like this and the other one is pushing upward. So it will cause anti-clockwise moment, so moment become positive value. Okay. Okay, let's try this example, which is sample problem 3.3. Okay, so let's read the equation. Okay, the plate in a shape of parallelogram is acted upon by two couples. Okay, two couples. Okay, so check first. Okay, oh yeah, this is the first couple, which is the F is at 84 Newton, and the second one is 48 Newton. Remember that the couple should be the same magnitude, opposite direction, and parallels in line of action. Okay, so these two couples fulfill the category as a couples. Okay, now solve the first one. The question asks you to determine the moment of the couple formed by 84 Newton force. Okay, so 84 Newton is like this. Okay, and the other one, okay. So you need to get what is the perpendicular distance between these two. Okay. So then you can calculate the moment. Okay, look at the second one. B, the perpendicular distance between 48 Newton force if the resultant of two couples is 0. If the resultants determine the perpendicular distance between the 48 Newton force if the resultant of the two couples is 0. Okay, so which means that the resultant of the moment for two couples is 0. So if you have one couple, F1 times D1 plus with F2 times T2, so it will become 0. Okay, let's solve for question A. The question A requires you to determine the moment of a couple formed by two force of 84 Newton force. Okay, so let's take a look at the diagram here. Okay, so we know that the moment can be determined by force times perpendicular distance d. Okay, so absolutely we know that the force value is 84 Newton. Okay, what about t, the distance, perpendicular distance? So if you notice here, okay, we just need to locate a ruler, will be easier. Okay, just place it between the two forces. Okay, so this is actually the perpendicular distance between these two forces, in which that the d is given originally from the diagram, which is 0.16 meter. So since we already have d value, just substitute into the formula, okay, and we can calculate the moment value. Okay, however, you have to identify first where is the direction or rotation of the moment. Okay, so imagine that you have one force at the bottom and the other force at the top like this. Okay, so in between these two forces, just imagine that you place a wheel or a steering. Okay, so imagine that these two kind of forces apply a force on both sides of wheel. So where is the rotation of the wheel? So the wheel will rotate in anti-clockwise direction, so M will be positive. Okay, so let's see the solution. So we know that the D value and F value. So then we can substitute and we managed to get the value of the moment, which is equals to M equals to 13.44 Newton meter, where the direction of the moment is anti-clockwise, so it is positive moment. Okay, so this is the complete answer. Make sure you give what is the magnitude of the moment, the units of the moment, and the direction of the rotation. Okay, that's it for A. Okay, for question C. Sorry, for question B, okay, so the question asks you to determine the perpendicular distance, which is D, between the 48 Newton force if the resultant of two couples is 0. Okay, so according to this, okay, the question asks us to determine what will be the perpendicular distance between these two forces. Okay, if the resultance of the couples, the resultant of the moment due to couples is 0, which means that remember that we have two kind of the couples, which is the one that we determine in A, which is 84 Newton couples, in which that the value of the moment is actually 13.44 Newton meter. So the question in B is actually ask us what will be the perpendicular distance between the couples with force 48 Newton if the resultance between these two moments is 0, which means that M1 plus M2 will be 0. So we know that this is the M1, which is 13.44 plus with M2. Okay, so for M2, identify first where is the direction, whether it's positive or negative. Okay, so based on the rotation, so the rotation of this due to this couple will be in clockwise. So it means that it will be negative M2 equals to 0. Okay, and since that for M2 is actually F2 times D2. So D2 is actually the perpendicular distance that we want to determine here. And F2 is actually 48 Newton. Okay, so just substitute, okay, into the equation. So it's end up that you will get that the D2 is equals to 0.28 meter. Okay. So here it shows that the moment can be summed up together. Okay, so in this case, the summation of the moment is equals to 0. Okay, and then after you know any of the information, just substitute and determine the unknown value. That's it. Okay, let's move to question C, in which for question C, we are required to determine the value of alpha if the resultant couple is 2.88 Newton meter clockwise and D is 42 centimeter. Okay, so we need to determine what will be the angle here. Okay, and it is known that okay the resultant of the couple is 288 Newton, which is M total in this case is 2.88 Newton meter, and distance here D is 42 cm. Okay, so let's solve the question. Okay, so actually the D2 here is actually from here to here. Okay, so well, we know that the M total in this case is 2.88, so it comprises of M1 and M2. So for M1 is already know that it is 13.44. Meanwhile for M2, which is in clockwise direction, so it should be negative, okay, FD, okay, F times with the perpendicular distance, okay, perpendicular distance D, okay. So the D here is actually, we get it from this formula, okay, and then F here is you just substitute the value of F given, which is 48. Okay, I will show you how can we get the alpha here. Okay, so actually the force of 48 Newton, okay, is like this. Okay, and the distance that's provided to us is actually this one. This is 0.42 meter or 42 cm. And the perpendicular distance that we need to substitute into the equation is actually this value, and we need to get what is the alpha value. Therefore, okay, in order to get distance here, okay, it is actually equals to 0.42 times with the sine alpha, because sine alpha is actually the perpendicular distance here divided by the hypotenuse, which is 0.42. So we want to know what is the D2 to be substituted into here, and this one is related to this. Okay, so we substitute again all the value into equation. So 2.88, 13.44 for my with m1 value, and minus with 48 Newton, multiply with the perpendicular distance, which is 0.42 sine alpha. Then after we modify, and then we will get what is alpha value. So let's take a look at the solution. Okay, so the alpha value is actually 54 degree. Okay, that's it.